So today we are going to see named entity recognition, one of the most important NLP model that need to be developed to identify the names, because they are the most important aspects in the text again. So what is named entity? Named entities are anything that can be referred with a proper name, either a person name or a location or an organization. So the task in named entity recognition is we have to find the spans of text which is going as considered to be a person, a location or an organization. So then tag their type. So it is a fundamental task in natural language processing. So it's typically most of the named entities are noun phrases, right? So they refer to specific types of individual, places, things. So now it's actually include not only person or a location or a organization, it also includes dates, times and other kind of temporal expression, and sometimes even numerical expressions like prices are part of the named entity identification. So for example, when you have a sentence like this, Marie Curie was born in Warsaw, Poland and later studied at Sorbonne University. Now you could see Marie Curie is one named entity, it refers to a person, and Warsaw, Poland is other named entities, it actually refers to a location, and Sorbonne University is another named entity, it refers to an organization. So identifying this is important because for multiple other tasks, identification helps us to make sure that, let's say we are working on a machine translation task, these kind of terms should not be translated, and rather it should be transliterated according to the target's requirement. Okay. Now identifying and classifying the named entities in a text actually part of different activities. So we are extracting the valuable information from an unstructured data. So this data may contain personal names, organization names, location names, date and expressions, monetary values and percentages. So all these entities, now we call them as named entities. And it's important, as I told you, for information extraction, question answering, summarization, machine translation, wherever the language plays an important role with a lot of entities, so identifying them is very much important for us now. Now, some of the elements we should not again confused with what are named entities and what are not named entities. So for example, hotel looks like a named entity, but it is not a named entity, whereas Taj Hotel is a named entity because it's one term which actually expresses one entity. So flower is a very common term, whereas rose flower is a very specific flower. So similarly, beach, Kovalam Beach, airport, Indira Gandhi International Airport, the school, Good Shepherd School, Prime Minister, let's say the former Prime Minister Mr. Manmohan Singh. So now all this comparison makes sure that this is not a named entity. They are all generic terms, whereas the one which are given in blue colors are named entities because they are very specific elements. Let's see the examples of different generic named entities. So person, organization, location and geopolitical entities are part of named entities, and each one of them you could see with the sample categories. Person is not only person, even the characteristics of a person is also being called as person. You could see in this example Turing as a kind of test used like named after a person is a giant of computer science. Now it's a person. And similarly, IPCC warned about a cyclone, so it's an organization. And Mr. Sanitors in Sunshine Canyon, so again this is a location. And Palo Alto is raising the fees for parking. Now this is again geopolitical entity. So any output of named entity recognition looks like this. So it's trying to identifying the named entities, different kind of named entities, and trying to put the subtypes. So as you could see in this particular text, you could see a lot of named entities are being identified with their subtypes. For example, United States Airlines as an organization, Friday as a time, $6 as a money, American Airlines as an organization, even American Corporation is an organization, Tim Wagner as a person, and United is an organization, UL Corporation is an organization, and Thursday time, Chicago location, Dallas location, Denver location, San Francisco is a location, right? So in a given text, in a paragraph, we might end up identifying multiple named entities. Now, why do we need to do it? One, for example, in sentiment analysis. So, identifying sentiment behind a particular entity is important for multiple application. For example, when we are buying a product like iPhone 14, whether it's been used more positively or negatively, identifying the named entity which is being associated with that sentiment is helpful for us. And question answering uses a lot of named entity information because relevant entities are useful for answering the queries. So when you have a question like who is the CEO of Apple, so now the named entity who requires a named entity of a person, right? So it might able to give you Tim Cook. Sorry, it might able to give you Tim Cook. And information extraction. So building structured data from unstructured text, where we could use the NER. So for example, extracting any company names, financial figures from news article, we could use the NER. And for semantic search, again, NER plays a very important role to get the relevant information. So for example, when you search for restaurants, so it has to identify the entity type, then it has to also identify the other subtypes like Italian, vegan kind of thing. So again, NER will be useful. And content recommendation is also uses NER heavily. So recommending news article, let's say Elon Musk, if a user frequently reads about, let's say, SpaceX, right? So, and having said all these things, the NER is different from other, again, tools. For example, event recognition is another tool which is not an NER because here events are not being identified. Let's say marriages, functions, or any other programs, conferences are not, the terms are not actually named entity. And template creations, for example, NER will not have a same template across all tasks. Semantic search requires a different kind of template, whereas the question answering requires a different template. And template creation again is a totally different task which is not part of the NER. And co-reference and entity linking are different tasks, they are not part of NER. And simple text matching is again not the NER task. So as having said all these things, NER again is not an easy task, whatever we see in the text which is a proper noun, we cannot get into into NER. We have to also see what kind of types of NER it belongs to and how to identify them from the guideline that we prepare for a particular task. Okay. Another important thing that we need to understand is tagging. So how are we going to build the NER annotated data? Because when we are working with any stochastic or machine learning or a deep learning based approaches, we need an annotated data. So for tagging scheme, B is used for beginning of entity and I is used inside entity and O is used outside any entity. So unlike POS tagging, where in POS tagging case, we are trying to give a word associated with a particular tag. But in NER case, it is span of text. More than one or two words may belong to one particular named entity type. So to identify that one, B is used as a beginning of entity, I is used as an inside entity, and O is used for outside of an entity. And for example, when you have a sentence like Jan Villeneuve or United Airlines. So for example, if you see Jane Villeneuve of United Airlines. Now, Jane Villeneuve is a person and United Airlines is organization. But in the case of Jane Villeneuve, you have a beginning of an entity and inside of an entity, and similarly in United States you have a beginning and inside. So this is being identified through the BIO tagging system of NER. So other variants of bio taggings are only using I and O, not use the B, and also use E and S an extra element, where E is end of multi-token entity and S is single token entity. Now let's get into the example case. When we have a text with multiple tags that are identified, bio or IO tagging will help us to identify the internal features. For example, IO label identifies I and O information that are associated with it. Bio label helps us to identify B, I and O, and bio ES label will help us in a different way. For example, when we take something like United Airlines holding, let's say this is an organization. This organization in IO label is given as all I, but it's an organization. And bio label on the other hand also tells us this is the beginning of the entity and there are internal entities inside. And bio ES label help us, okay, this is the beginning and there is an E and there is an entity that is being closed here. Okay, and the single elements are also given in a different tagging in all these variants. And there are many tagsets that are being built for NER. So automatic content extraction, this is called ACE tagset. It is a hierarchical structure. So entities like person, organization, locations are being used. And CLAA tagset is a very old tagset again. It's again hierarchical, similar to ACE, and mostly health, tour and health domains are being considered. And NAMX is another type of NER tagsets. It's here categories like person, organization, locations are being used. And NUMEX is only used for numeral expressions, and TIMEX is used for temporal expression. And you could see the NAMX tagsets over here. There are multiple tags under which there are multiple other subtags. There is a person and the person is being identified whether it is an individual or a group, and if it is an individual, is it a family name or a title, right? So similarly, all other tags are being grouped under multiple subtypes to identify what type of named entity it belongs to. And now let's go into the task. Now we identify the named entity. We have, let's say, a good annotated corpora with us. Now how to actually build a model. Now this is a kind of sequence labeling that we have to use because it's a standard algorithm for named entities. So sequence labeler is trying to label each of the text that indicate either it has a presence or options of a particular tag or what kind of named entity it belongs to. So standard algorithms similar to POS tagging, here NER also uses hidden Markov model and conditional random field, maximum entropy Markov models, and other supervised machine learning models are also being used. And recently either neural sequence models or LLM kind of models are also heavily being used in building the NER. So in the next few lectures we will see these statistical approaches in detail, how these models can be used to utilize or building POS and NER models. Okay, having again said that, is the NER is an easy task? Especially when you are looking at each language. Every language encodes the named entities in a different way. There are different kind of challenges that we face when we are working on this particular area. One is segmentation ambiguity. So unlike part of speech tagging, where each word gets one tag, NER involves identifying and labeling the spans of text. Right. So here the ambiguity or identifying the correct span is a actual problem, and determining entity boundaries is another challenge with the NER, because it's necessary to decide what constitutes an entity and where the boundaries lie. Many words in a text will not be named entities because it complicates us identification process. And type ambiguity is also there. Sometimes a same named entity will be used as a person in one place and it is used as a name of an organization in another place, right? So identifying the category which it belongs to is another challenge. And category definitions and metonymies are again important thing, because entities that overlap or span multiple categories. So for example, especially the category definitions are intuitively quite clear, but there are many gray areas too. Some of the areas are caused by metonymy, like something, what is a person, what is an artifact, what is an organization and what is a location, what is a company versus artifact, location versus organization. So this kind of metonymical differences across this, identification will create a challenge. Again, there are different types of ambiguities which comes because the names are ambiguous, like apple as a company or a fruit. And again, boundary ambiguity, for example, New York can be a part of a larger city. So now the New York city is a major city in the New York state. Now whether it is a state or a part of the New York state, right? The city versus state problem comes. And even overlapping entities. So for example, sometimes the entities overlap and span multiple categories. For example, Barack Obama as a person and President Obama as a title, right? So Barack Obama was the President of the United States. Now let's again go into some of the realistic example. Let's take the paragraph with word Washington. So now Washington is being used in multiple senses in this particular paragraph. So Washington as a person was born into slavery on the farm of James Burroughs. Washington as an organization went up to 2 games and in the 4-game series. And Blair arrived in Washington as a location, and in June, Washington is a geopolitical entity, passed a primary seat built law. So now this is the most difficult thing, right? In each of the cases, it's actually carrying with different kind of named entity relation. And other than that, Indian languages do have their own issues, because India belonging to several language families like Indo-Aryan, Dravidian, Tibeto-Burman, Austroasiatic and other language isolates, Andamese, Nicobar kind of other language families are also been part of our country. So it actually create different kind of issues. One of the issue comes from morphological richness. So a lot of informations are actually written together within a word. So agglutination is a very common phenomena. So this is again a difficult thing, because when a word is agglutinated with another non-NER word or NER word with a lot of inflection and other derivational markers, identifying the span and properly identifying that particular word is a challenging thing. And again, in Indian languages, we do not use any capitalization method, unlike English. So here Indian languages lack capitalization as a feature. And ambiguity, as we know that it's very common, especially in the proper noun. Let's say Roja. Roja means a rose flower, but it is also a person name, right? So the context plays a very important role to identify the named entity now. So other challenges include spelling variation and low resourceness, because we don't have a pre-processing task like part of speech tagging or chunking that might help the NER in multiple ways. So the tools that do not exist often have a lower performance, and lack of annotated data is another problem. Only a few efforts or a few annotated data available. One of the recently available annotated data even come from AI for Bharat's efforts. And scarcity of easily accessible this annotated data to the community is another issue with us. And now how to evaluate it? Similar to POS tagging, this is also kind of sequence labeling task. So the metrics like precision, recall and FN score can be utilized even to evaluate the named entity recognition. Now modern metrics like exact match ratio that actually measures the proportion of entities that are correctly identified with exact matches, and entity level FN score is also being used, where it evaluates the precision, recall and FN score of the entity rather than the whole token level. And other challenges in the evaluation is, of course, the consistent annotation guideline is very important. That is actually important for the evaluation procedures too. And partial matches again are creating another problem. When you say, let's say President Obama, only Obama is being identified, that is a big trouble. And cross-domain evaluation, for example, you are testing it with different genres, the same named entity, annotated data being trained on a particular domain but tested on another domain is create a lot of challenges. And similarly, cross-lingual evaluation, that means you are building that NER for a particular language, but you are testing it with another language, because it's very common. We know that named entities will not change the baby equivalents. It may have a similar equivalent in most of the languages. When we are leveraging it for cross-lingual context, assessing the performance across languages are a problematic thing. But having said that, NER plays a very important place in the natural language processing for the tasks like summarization, information extraction, machine translation, and other NLP applications. Thank you.